All right, so properties of equality, it says number one, the addition property. If A equals B, then A plus C is equal to B plus C. Basically, it just means that we can add a constant to both sides of the equation at any time. Add a constant to both sides of the equation at any time. Have you guys ever seen the old style
Is it always lowercase letters?
for the most part, yeah. You ever seen the old style balance or scale? Where they used to weigh things? You ever seen that? Siler? 46. The picture's not on there, but have you guys ever seen this picture, like a scale like this? Alright. This is a good thing to keep in mind when you're looking at this because you always got to keep the scale balanced. If you add a number to one side and not the other, then all of a sudden it's going to get unbalanced. You always got to keep the scale balanced. Okay? And so properties of equality mean that we're keeping things equal on both sides of the equation. This is like your equal or your balance. It's got whatever you do to one side, you have to do to the other side. Okay? That's the addition property. The subtraction property means the exact same thing. If A equals B, then A minus C is equal to B minus C. Means the exact same thing. The next one is the multiplication properties. So if A equals B, then I know that A times C is equal to B times C. I can multiply by a constant at any time. Which makes sense. If I have 3 equals 3, I can multiply 3 times 2, and that still equals 6 equals 6.
You're going way too fast.
So the multiplication property to solve equations means you can multiply both sides at any time. Same thing's true for the division. If A equals B, then I can multiply each side of the equation by the same value. Reflexive property you don't use much in algebra, but we do use it in this class. A equals A. We'll use this in proofs. Reflexive property. Symmetric property just means that doesn't matter the order. If we have if A equals B, then we can switch the order and say B equals A. Doesn't matter which one comes first. If they're equal, they're equal. Doesn't matter if it's on the left or on the right. Okay. Transitive property. One of my favorites. Transitive property says this. If A equals B and B equals C, then A equals C.
Are we videoing this for gamers?
Let's see. Kylie, how tall are you? Huh?
She said 5'7", she thinks.
5'6", okay. So here we go. the transitive property says if I'm taller than Kylie and Kylie's taller than Hope, then I'm taller than Hope. Work your way down the line. That makes sense? If I'm older than Maggie and Maggie's older than Keithan, then I'm older than Keithan. Now that's kind of an inequality, but it's also true in transitive. So we could say if A is greater than B, I'm older than Maggie, and B is greater than C, Maggie's older than Keithan, then I am older than Keithan. Okay? So the equality of it works, but so does the inequality. The transitive property works all the way down. All right? Any questions there? It also works backwards. If C equals A and C equals B, then B equals A. It also works backwards. Okay? All right. Last one on these properties. Substitution. Now, the substitution property is very similar to the transitive property. Okay? But if A equals B, then you can substitute A for B. I like to use the word replace. You can replace A for B anywhere. Okay. We're going to use substitution a lot. And you probably have an algebra. Lainey, does that make sense? All right. Turn to the top of the next page. Look at example B. At least, can you read off example B for me at the top of the next page?
9 equals 17 minus 4x.
Say it again.
9 equals 17 minus 4x.
Okay, so this is basically just an algebra 1 problem. Let's walk through it slowly. Maddie. Good morning, by the way. How do I solve this? What would you do first? We want to isolate this x, correct? We've got to get that x all by itself. Well, it's being multiplied by 4, so we don't want to divide by 4 yet. That'd be the last thing we would do. So we want to isolate this term. So we have to undo whatever they're doing. What are they doing? They're adding 17. How do I undo a positive 17? How much? She said take 17 from both sides. Or subtract 17 would be probably the proper math way to say it. Subtract 17 from both sides.
I remember the hours.
And so we're trying to isolate the variable. 17 and 17 cancel out. What are we left with over here? Don't forget that negative. It stays. It doesn't disappear. Negative 4x is still there. What's 9 minus 17, Smith?
I'm so confused on what's going on. How did you...
Hold on, Keithan. Smith, what's 9 minus 17? Negative what? Very good. Negative 8. All right, Keithan, what's your question?
It clicked.
Okay, so now we have negative 8 is equal to negative 4x. We have to undo whatever they're doing, Bailey. What are they doing to our x? So right here's our x. What are they doing to it? Are they subtracting 4? No, they're not. Very good. They're multiplying by negative 4, aren't they? How do I undo? I'm going to even write that word down so you can recall it. How do they undo multiplication? You do the opposite property, which is division. So the division property of equality means that we divide. Do I just divide by 4? Negative 4. Whatever I do to one side of the equation, I have to do to the other side because I got to keep my scale balanced. Does that make sense? Careful on my equipment here. 90. What's negative 8 divided by negative 4?
Two.
Hold on, say it again.
Is it two?
It is 2. I asked you, don't ask me the questions.
I said I was probably gonna get it wrong.
That's right. What happens when you take a negative divided by a negative? It becomes positive. You remember those rules? Maybe we need to review. What's a negative times a negative? Positive. What's a negative times a positive? Negative. What's a positive times a positive? Positive. What's a positive times a negative? Negative. Remember those rules? Same thing are true on when you're dividing. What's a negative divided by a negative? Positive. What's a negative divided by a positive? Negative. What's a positive divided by a positive? Positive. What's a positive divided by a negative? Negative. We're good? Quick Algebra 1 reviews. We're good there? All right, let's move on. Did we get the final answer, by the way? Oh, yes, but awesome thing for algebra. We can always check. It doesn't tell us to check, but we can check because we are so relentless in getting the right answer. So to check, we're going to go 9 equals 17 minus 4. And I'm going to use the substitution property. I'm going to replace the x with a 2. And I'm going to verify that this is proper. Lainey, what's 4 times 2? Kylie, what's 17 minus 8? Huh? No, you don't. Got one right there. You just got to use it. 17 minus 8 is 9. Okay? And so we know that it's correct. All right? Questions? Did the book tell us to do that? No, it did not. We still did it. Go to the top of the next page, page 48. Linear pair. If you don't have this in your notes, you need to get it in there. If you have it in your notes, great. Linear pair theorem. THRM is a abbreviation for the word theorem. It's a pair of adjacent angles. Ooh, good geometry term. What does adjacent mean? Adjacent means it's right next to each other. Keithan and Maggie are adjacent to each other. They're right next to each other. Okay? My home, where I live, we are adjacent to the Botkins. We're not across the street. See, we're adjacent. We're right next to them. That's what it means, adjacent. Okay, so when we look at a picture, we've got two adjacent angles. They're right next to each other. I'm going to call this angle 1. I'm going to call that angle 2. So angle 1, the measure of angle 1, plus the measure of angle 2. How many degrees are in a straight line, Smith? 180. Thank you very much. Very fundamental thing of geometry that we will talk about all year. 180 degrees. If you can't see it, 180. You can use your protractor and look it up. You will need your protractor, I believe, for the homework. Make sure you have one.
Those ends.
Measure. Yes, those are small m's. They represent the word measure. The measure of angle 1 and the measure of angle 2 is 180. So let's do a few math problems in our head, Lainey. If this is 120 degrees, what is angle 1?
It's 60 degrees.
How far is it from here to here, Lainey? $180. So if that's 120, how much is left? Very good. Laney can get there. Takes her a little bit. She can get there. Nicholas, you're up. If this one is 45, Nicholas, what's angle 2? Can you do it in your head?
Yeah, I'm doing it in my head right now.
All right.
$135.
Very good. Maddie, we'll give you a more difficult one. I know you were hoping for that. She's like, no. Yes, just because I can find you. All right, you ready? Let's say that this one is 15. 165. Very good. See, it wasn't that difficult. We'll give Hope the most difficult one. Let's say that this one is 168.
There's so many numbers, I don't even know where you got it from.
I'm creating them from space. What's the whole straight line measurement? And if that one's 168, how much is left? Close. 168.
Oh,
You are right. 12. 12 and 168. You guys get the idea? We could do this a lot, okay? But basically, this is the equation for a linear pair. The measure of angle 1 plus the measure of angle 2 equals 180. If I know one of them, I can find the other one. Right? And you guys all did it in your head, little subtraction problems. We will use the idea of adjacent angles a lot in linear pair theorem, a lot when it comes to proofs. As we go forward. Good? Okay. Let's go to the right below that page. It's example B. Chase, can you read off example B? Like what's given?
The measure of angle RST
Is it an angle? No, not example. Oh, did I say B? I'm sorry, I meant A at the bottom of the other page. My mistake. I even wrote B. Sorry. A.
given RT
Mhm.
equals 5x minus 12.
Okay, so there's the, we know that the whole thing is 5x minus 12. Now S is positioned, looks like about in the middle, doesn't it, Landon? It's close, isn't it? Landon, what's the length of RS? So do you see how I draw that in to show that it's length of RS, like that? Okay, you gotta get pretty good at that. Michaela Bond, what's the length of ST? Okay, so by the segment addition postulate, which we've already discussed, remember it, by the segment addition postulate, I know that RS plus ST is equal to RT. Simmons, you see that? RS plus ST is equal to RT. Does that make sense to you? Okay, without all the numbers, because some of you struggle for looking at anything like that, R, S, T. RS plus ST equals RT. Does that make sense now? Does that make sense? Maddie, does it? Keithan?
Can you say it again?
You see from R to S how that's a segment?
Yeah.
You see from ST that's another segment? If I combine those and make it into a long segment, what's it equal to?
RT.
That's it.
So basically you just take the middle
All right, does that make sense? Now we're going to create an equation with what's given just by substitution. I already asked this question once, but I'm going to ask it again. What's the length of RS? X plus 2. So I just replaced RS with X plus 2. What's the length of ST?
3x minus 8.
So I just replaced ST with 3x minus 8. And then what's the length of RT?
5x minus 4.
So I just did the substitution property 3 times. That makes sense? I put the length x plus 2 in for RS, 3x minus 8 in for ST, and 5x minus 12 in for RT. Now we need a long algebra problem. Mr. Rhodes, help me out here. What would you do first?
Let x plus 2 plus x, or 3x minus 8 equals 5x minus 12.
Okay, that's what I've done. What would you do next?
You subtract 4x on both sides.
Okay, you're a step ahead. How did you get 4x?
Oh, you combine.
Thank you. That's all I wanted to hear. No, you're good, Micah. Good job. I'm going to come back to you. He said combine. The proper algebra phrase is combine like terms. Same variables, same powers. Remember that, Jadlin? So x plus 3x. There's a 1 in front of the x, even though we haven't written it there. X plus 3x is 4x. So that combines those terms.
So it'd be 4x plus 2.
So what's plus 2 and minus 8? Are those like terms? I'm going to put arrows above those. Okay, what's positive 2 minus 8? Micah? Negative 6. Very good. So that combines those terms. And now we're still equal to 5x minus 12. Michaela, what would you do next? No. We got to get the x's on the same side. So anytime you've got an x on one side and an x on another side, you have to get the x's combined first. Okay? So since I have 4x on the left and 5x on the right, do you want to subtract 4x or do you want to subtract 5x? It does not matter. I personally would probably choose to subtract 4x. Does that make sense? Okay. So let's subtract 4x from both sides so we can get the x's on the same side of the equation. So now I have 4x minus 4x. Those eliminate, cancel out. I have negative 6. Don't forget that negative out in front of that 6. 5x minus 4x is just x. If there's a 1 in front, I don't need to write it. And then I still have a minus 12. Okay, Michaela, back to you. Now what would you do? Do you remember? I'm trying to isolate this variable, right? Trying to solve for x. What are they doing to that variable right now? Subtracting 12. How do I undo a subtraction?
Add 12.
I add 12. Do you remember that, Michaela? Okay, so I have x minus 12. I'm going to add 12. Whatever I do to one side of the equation, I have to do the other side to keep it balanced. It's all coming back to you, Hope.
Cross out the 12s.
12s cancel, and I'm left with x over here. What's negative 6 plus 12? Does it matter if it's 6 equals x or x equals 6? Nope, same thing, called the symmetric property. Haha, we're done. Maddie, you remember all that? Okay, now the book doesn't ask this, so this is free. This is extra. I'm not going to charge you for it. What if they ask us, what's the length of RT?
It's 6x.
Nope. What's the length of RT? Nope. We know what the value of x is. Oh,
Would it be 17?
close. Your math is close. I think you did the right thing. I just don't think you did your math right. Wheat. 18. How'd you do it? Oh, for the rest of us.
Put the 6 into the
Very good. It's called substitution. Just take the value of 6, substitute in for x. Did they tell us to do that? No, but they might on the homework. Okay. That was free. I didn't charge you anything for that. You'll use it a lot. You go for it. Okay? Riley, got it? Maggie? Good. All right, let's turn the page over. Now, Chase, we're going to do B. That was my mistake, Chase. I like blaming other people for my mistakes. Don't I, Maddie? Okay, read it off for me, Chase, if you don't mind. Okay, so the measure of angle RST. Well, let's get the picture right. R is on this ray. S is the vertex. Ooh. T is on this ray. And then they've got one that goes in the middle, don't they? What's the letter that's in the middle, Chase? Is it P? Thank you. Okay, so by the angle addition postulates, what time we get out of here? 10:22. What time is it? Oh yeah, we got plenty. By the angle addition postulate, we know, now watch this long equation, RSP. Where is that at? I'm going to color it in a little bit. There it is. There's RSP. Everyone see it? Plus the measure of angle PST. I'm going to color that in, but with a different color. You see those two different angles? If I add those two together, very similar to the segment addition postulate, James, what do they equal? So look at
I'm so confused with
this small angle plus this small angle. What does it equal? Not in value. What angle does it equal? Can you name the angle? Yeah. Okay, so here's the small angle. Do you see how I've colored it blue, Keithan? Do you see that?
Yes.
Here's the angle that I've colored mauve. You see that? If I add these two angles together, it's just like the segment addition postulate. Wouldn't that just equal the larger angle? What's the name of the larger angle? RST. That is called the angle addition postulate. Okay, so now let's do a big substitution. Okay, Jalen, help me out. Instead of writing the measure of angle RSP, I want to give an expression. Look in the book. What do they say that the measure of the angle RSP is? Say it again. Very good. So instead of writing that, I'm going to write x plus 25. I just replace it. That's all. Landon, does that make sense? Okay, go ahead and do the same thing for me for PST. What's the measure of angle PST? 5x plus 10. I don't want to go too fast. All I'm doing is going straight from the book. By the way, do they have blanks in the book that you can fill in? I think we've done everything that you need. If you want to fill them in as we go, that'll help you. So you can go back and look at it. All right, and then what did they say the measure of angle RST equals? 15x minus 10. What I wrote down at the beginning. So equals 15x minus 10. Notice how we go from letters in an equation to numbers. That makes sense, Elise? Lily? Hope? Good? Okay, so now we're back to this. Very similar to what we had up here, where we have to solve for x. Carter, help me out. What would you do first? Combine like terms. Very good. That's the proper phrase. What's x and 5x combined? 6x. Good. Okay, what's 25 and 10 combined? Good. Maddie, what do we do next? Okay, what are we subtracting? I agree. I'm going to subtract 6x from both sides because I got to get the x's on the same side of the equation, right? So that cancels these 6x's. I'm 35 over here. What's 15 minus 6, Maddie? I have 9x minus 10. All right, Keithan, let's pick up there. We have 9x minus 10 over here and 35 over here. I'm trying to isolate the x. What do I do next? Add 10. Very good.
So you got 45.
45 equals 9x. Colby, what do we do next? Colby, you're a good math student. 5 equals x. Questions? You know one way I like to think of the substitution property? When we lived in Bourbon, Indiana, we had our neighbors, good friends of ours, the Masons. They actually both girls ended up graduating from Butler, but when they were in second and third grade, they're twins. Kylie and Kaylin. Kylie's like, I don't want to go to that class. Kaylin says, I'll go for you. And she did. And so she went to the class that Kylie didn't want to go to. And the teacher couldn't tell them apart. They were identical twins. The only way the teacher figured it out, because she called for Kylie and said, hey, Kylie, can you do this? And Kaylin didn't respond. Because her name's Kaylin. And then she realized, oh, wait a minute. So they got in trouble. But that's the idea, twins substituting in for each other. Simmons, you ever do that with your brother? Are you guys identical? No, what's it called when they're not identical? Fraternal? You guys have a lot of twins in your grade, I've heard. We talked about this last period. Who else do you have in the sophomore class that are twins? Who? Yeah, the Henshaws. Of course, they're not identical. There's another pair. Hoffs. Hoffenbarger. And I don't think they're identical either. Is it just those three? No, Michael told me they weren't. I mean, Trent, I had last period.
They're opposite. They're opposite. Like one's left-handed, one's right-handed.
Are there any others in your grade? Junior class, you guys have any? Seniors? No? We had 5 in our graduating class. Hey, homework's due tomorrow. Okay? And it's posted on Canvas. All there for you. Yeah. Same one that was posted yesterday. Due tomorrow.
I didn't do it last night.